Hello, namaste. It's me Rohan, and in this video we will learn to estimate OLS or the ordinary list squares in Python. First of all, we must import these packages, and I'll zoom it little. We must import these packages. Import pandas as PD, import numpy as np, matplotlib pyplot, and sequence if necessary, and this is and these codes are optional. You can write it or you can leave it out, and these packages are most important for this video tutorial. We must import statsmodel.api as sm, and we must import statsmodel.formula.api as smf. We will use this for OLS. We will use this for OLS, and we can use it for other regression also, such as logit. And the second package, we will install it from the same package, that is import statmodel.tsa.stattools as smt. Since we are doing the time series model in it, we must test its stationary. So we will have adf test here. And for the last, it's import statmodel.diagnostic as smd. It's the package for diagnostic test. And OS, it's package diagnostic tests such as head test or test for heteroscedasticity. Heteroscedasticity. Sorry, my spelling is mistake. Yes. Heteroscedasticity. So now, first of all, I want to import data, and it's stored in my local drive. It's in local drive. And first of all, I want to calculate its head. First of all, I want to register and clear all output. First of all, I want to see my check or my data as df.head, and the df.head, sorry, we have restart. We must first run this code, and we must run the second code, and the third line is df.head. It will give the top 5 data, gives top 5 data. And we also check, let's check its tail also, df.tail. It will give the bottom 5 data. It's all, I think it's all okay. And let's describe it, and it will give the descriptive statistics. Something is mean, and it means that I think it have outlier in it, because the uh, mean and the median are far away. It means that the data is skewed. Let's check the data info. It will give the information about data. First is it's not null. It's okay, but the d type is object. It must, I think the month must be a date type. So we will change the month as date. It is necessary to change the data type of variable month. So now to change it, we will write a df month, pd.datetime index, and we will give the name of column. And let's check it data info. Now it's date time 64 ns. It was object previously. So now let's change the name of the column as imports, because why are we doing this? Python has a inbuilt function called import, so we must change the name of column. So now we must rename it. To rename it, we will write as df equals to df.rename columns equals to, we are changing the name columns, so we must write columns equals to import imports, and hitting enter. Let's check the info. Now it's imports return, it was import. Since we are doing the time series data, so we must plot the, so it's better to start our analysis with plot. Sorry, let's add a column above. And since we are doing time series data, we are working on time series data, let's have a line plot. So now if I simply make it as a comment, then plt.plot df month is x axis and df import is y axis. I am plotting of import. And if I need to add a title, then I will simply write as plt.title. Let's make this graph a bit small, it's too large. Let's make it 8. I think now the graph will be a bit small. It's small now. We have a title called time series plot.imports, and let's add the level plt.x level, plt.y level, and if I add it, then the graph will be somewhat looking this. So now I am speaking these lines. Since the monthly data is somewhat like a mountain, it's fluctuating, it's increasing and it's decreasing over a period of time, and this is due to the method of collecting the data. It means that import will be 0 in the start of the month, and it will be maximum at the end of the month, because the import data are cumulative in nature. So we will perform our analysis in the yearly data, estimating the OLS in the yearly data. So for this we will have a new column called year, and the pandas is very useful in it. Pandas can separate the year from the date. It means that the month, and if I check, let's check it once, df, then the month data has year data, month data, and the date or the day data. And the pandas is useful to separate year, month, and day. And we can do it by df year pd.date time index and df.month.year. If I do it, then it will only take the year from this whole data. If I check it, then it's only year here. So now let's make a new data frame from year, and this line says that df underscore yearly equals df imports cpi m2. It means that I am only taking import cpi and m2 from the data frame and group by df.year. I want to group the data by day of the year, and I only want the last value of the year, and it's day of the yearly. And here I want to drop this last column or this last row, because because we have only 3 data for this year, so I want to drop it. I will drop it by writing drop it's 2022. If I do it, then the last data will be erased. So now let's run the OLS in it. The OLS formula is OLS equals to, you can write as, its formula is OLS equals to SMF. SMF if is the method we have written here, it's the SMF from here, is start model formula dot API, it's the method inside it. SMF we have curled start model dot formula dot API as SMF, and we will call the method inside it, that is OLS is the method inside it, and we will write as dependent variable, and we will write the list of independent variables, iv1 plus iv2 sorry plus iv2 and so on. We will continue it plus ivn, we'll continue it, comma, we will write as data, means that we will give the reference to our data frame, its data frame, and we will fit, and we can also have the option here, uh, such as we can also have the covariance type here. We can have a robust covariance as HC1, it's the covariance type, and that is robust to the problem of heteroscedasticity. And if I write it, and this is the formula for it, I have written the same, OLS equals to SMF, it's the stat models dot OLS is the method inside it, and I have written, and the CPI is our dependent variable, imports and M2 are our independent variables, data equals to, we have the data in df yearly, and we want to fit OLS, and we want to print its summary. And if I hit shift enter, then the OLS is readily available here. First of all, we can check it from here. It's the dependent variable is CPI, and the model is OLS, method is least squares, date time its number of the is of 22 years, df residuals is 19, it means that df means it's 22 minus 3, it's the intercept, imports and m2 minus, it's means that 1 2 3, and there are 3 regressors here, means that 2 regressors and 1 intercept, so the degrees of freedom is 22 minus 3, it's 19, and the covariance type is non-robust. If I want to make it robust, then I can write as COV, sorry, I think this option will not work here, sorry, this option will not work in this case, and print the summary or else we'll grip it. So now the second is r square, it's 0.939, it's okay for the time series because it will be high in case of time series, and the f statistics is 14.147.2, it's significant, highly significant. So this says that the data fits the model well, and the AIC and BIC, it's only to check the model, and the lower AIC and lower BIC as preferred. So now let's go to the coefficients. The import coefficient is it's too small because we haven't taken it in log scale, so it's better to take in log scale. I think we can take the log scale also, we can practice it here. I want to make the log scale, so yearly I want to take as lncpi, sorry, let's lncpi equals to np dot, it's the numpy function, lp dot log. I want to make of df, it's cpi. Similarly, np dot log, log df underscore its imports. I want to make as the ln imports is ln m2 equals to np dot log df it's m2. Now hit enter. So now let's check our yearly data frame. I think it's okay here. Dot mm, it's showing not available here because I think it is something np dot log df imports. Oh, sorry, here is the mistake in the data frame. It must be earlier. It must be earlier, and it must be early. I think now the problem will be solved. Now the problem is solved. So now let's run OLS again. I will simply copy it from above and I will paste it here, and I will write as ln underscore cpi and ln underscore cpi, sorry, ln underscore m2 and ln underscore I'll write as OLS. Let's change its name. I'll write as OLS and OLS, and let's print it. Sorry, it's showing that len imports, it's mistake here. So now let's check it. I think the coefficient are much more readable and much more interpretable in this case compared to the above. Yes, I think it's 0.00 something 5 zeros here in the above model, so it's better to take log. So now it is better to take log before carrying out any type of regression analysis. So now let's have a look over this second OLS regression. That is our different variable is log CPI model OLS, and it's all same here. R square is 0.996, and there's improvement in the R square, and the AIC is minus 84.45, and the AIC the above was 165 and is negative 84, means that this model is far better. The second model is far better than the first one, this model, since the AIC and BIC are less in case of the OLS. Means that if I write here OLS dot AIC, says let's print OLS does AIC and OLS dot AIC, then it's 165 for the model 1 and it's minus 84 for the model 2, means that the log model is far better than the non-logged model. And similarly the coefficient are, it means that 1% increase in import will increase the CPI by 0.0582 percentage. Similarly 1% increase in M2 will increase the CPI by 0.3996 percent. It means that the coefficient are also very easy to interpret. And looking about these results, I will only interpret the W Watson. It's 0.841. Since it's less than 1 or it's far from 2, so the model suffers from autocorrelation. And the other is it is smaller than the R square, so this coefficient might be spurious. This coefficient might be spurious. And second is the Zagabera test. From the Zagabera test, it is it is not significant, means that the probability of Zagabera is not significant, so we can say that the residuals are normal distributed. If I write it here, if I write the interpretation here, interpretation interpretation of regression results. First of all, let's begin with the R square. R square is 0.996. R square is mm, R square is 0.996, means that 99.6% of variation in independent variable is due to independent variables. And similarly, now it's F statistics. F statistics significant, so model fits the data well. And let's check its AIC. AIC of model 2 is less than of model 1, so model 2 is logged model. Logged model is better. Now let's its times of coefficients time. It means that 1% rise in imports increases CPI by 0.05%. Similarly, 1% rise in M2 or broad money supply. Broad money supply increases CPI by 0.4%. So now this is the result, and other results are and other results are of Durbin-Watson. Durbin-Watson. It is the test for autocorrelation, and it is far less than 2. So model suffers from autocorrelation. Model suffers from autocorrelation in our case. Also, D-Watson is less than R square. It's less than R square, so the coefficient might be spurious. To check if the coefficient are spurious, we need to check the stationarity of the residuals. We need to find these residuals and we need to check it. I think it's only up to here, and it's JV statistics. JV statistics, it's the statistic for normality test. Its null is residuals are normally distributed. It means that its probability JV is 0.88, so we cannot reject the null. We can reject the null. It means that the residuals are normally distributed, and these are the interpretation of the regression coefficients, regression result. Is the interpretation here. At first, to do manually, we must have residual squares, and we will simply regress it on our these variables, on our independent variables. As ln imports and ln m2. So we must create the residual squares, as OLS resid is the residual and we must create a square, so we must multiply it twice. If I do it, then I will get the residual square as in the data frame as shown here. I have done it by df yearly. I have added a new column name as residuals to OLS resid time OLS resid. And now let's run the Bruce backend test as smf.ols. We will run OLS, and we have only changed the lncpi from resid to. If I do it here, if I copy it, simply copy it, and if I paste it here, then it's all same, except I will change its name, and simply I will change its resid to. I will change resid to, and ln imports plus ln m2, it's all same. Dot fit, all is same, and simply I will change. So we must here look after only f statistics here. Our f is 3.154 and the f probability is 0.0657. So we cannot reject the null at null, and our null is model does not suffer from heteroscedasticity, so we cannot reject our null. And the same thing I can do it with the inbuilt function in the Python. So I will first call our package stats model as smd dot het dot het underscore Bruce package, and this package we have already called it as smt. This package we have already called it, and smt we will write as het Bruce package. If I write that het, then it will automatically give my option. So, and if I press shift tab, then it will give me hint. I must first write the sheet, and I must give the list of exogenous variable. It means that OLS dot receipt, I must give the receipt, comma, I must give the list of exogenous variables. OLS dot model dot, I must give the exogenous variable list, comma, if I write robust, then it will be true. Let's delete it for now. And if I don't write this anything else, and simply if I print bp het, then our result will be something like this: 5.432 0.064 3.15 0.0656 something, and no one will understand it. So to make it understandable, let's print the null. Null is the residuals are homoscedastic, and let's print the test statistics. The first one is test statistics, it's indexed at 0, so we will write test statistics dot, and we are telling Python that we are having a number here, and the number is of decimal 3, and the number is percentage bp het, it's stored here, and its index is 0. Similarly, we will write the p-value, f statistics, and the p-value for statistics. If I write here, then it's super simple, and now we can understand it clearly. It's exactly same. If I write it here as 57, and if I write it here as it's 5, then it's exactly same, 0.0656. Sorry, let's make it 4. 0.0657, 0.0657. You can check it here, same. 3.1, 3.154, 3.15 is same. And if you want the test statistics, then you can find it as here. I want to print it, print, and I want it as, yeah, I want only three decimal places, percentage 0.3f, and its percentage, sorry, something mistaken. For now it's 5.843, and it's same, exactly same, and it's for the chi-square test, and it's generally chi-square 2 because we have only two number of observations, two variables here, so it's generally chi-square chi-square 2, and chi-square 2 is 5.99. It's 5.99 at 5%, so we can reject at a 5%. So now for the interpretation, since p-value is greater than 5%, we cannot reject the null. It's same. And now here I remember that to check if the coefficient is porous, we need to check the stationarity of the residuals. So to check the stationarity of the residuals, I will first write as ADF receipt equals to SMT ADF fuller. It's the method for the ADF test, and I will write the name of the column or the variable. It's OLS.receipt, and if I do it enter, then at its p-value is, only look at the p-value, its p-value is 0.095, so we can reject our null at the 10%. That means that what is null? The null is that the model is non-stationary, so we can reject it at 10%. So now I will save my work, and you can check these all works from going to this link, jovian.ai rohanbjkr/ordinary least squares. I will share this link in the YouTube also, YouTube, in the comment section, and in the description, so you can go through it and you can practice it by your own. Thank you.